Hello everyone and welcome to my channel again. In today's video, we are going to understand the indexing in the MongoDB. Now, if you want to optimize your query within the MongoDB or any other database such as SQL, then indexing is a very important concept or a technique in order to improve your queries. So in this video, we are going to understand what is indexing, how to apply indexing, and what are the types of indexing which we can see in the MongoDB with the real-time examples. So without wasting any time, let's start the video. Hello and welcome back to this lecture. So in today's lecture, we are going to study about the indexing, which is a very important topic whenever we query our data in MongoDB collection. So it's basically a technique to improve retrieval speed of MongoDB query. So we generally know that whenever we query our data in our MongoDB, we use this syntax db.collection dot find, and this is our query, and here will be our projection for selecting limited fields from the document. Now imagine if there are millions of record or thousands of record, then this particular query will take more time in order to retrieve a particular documents. So indexing is a game changer concept which can drastically improve the speed of the MongoDB query. Now what it does, it maintains a B tree, which is generally a balanced tree. So here it is balanced tree. Now what it does, whenever we create an index on a particular field, it maintains a balanced tree, and within this balanced tree, node a node is represented as the key and the pointer to the document itself. So on the basis of the B, which is the balance tree, so it maintains the tree in a balanced way. So we can quickly look up at each nodes of the tree and we can retrieve the document accordingly. Okay. So it is very much similar to indexing in SQL. Now let us see why indexing matters. Let's take a scenario if we don't maintain indices. Okay. For example, there is a collection which is of users, and we want to find the user by its email. So let's say we query our data. So db.collection dot, so collection will be the user. Let us rewrite db.users dot find, then email. Let's say this is the email which we need to find in our collection. Okay. And consider there are 1000 documents in collection. So what this query will do, it will check each and every document and compare the fields. So here we are comparing the email, and if not found, we'll go to next document. So basically it is iterating over each and every document in our collection. So the average time complexity will be big of n, which is linear order of time. So let's say if there are 1000 documents, so it may take around thousands of seconds if 1 second is taken for retrieving a particular document, but the order of time is around linear. Okay, so this is the worst time complexity. And if indexing is applied, then directly we can look up for email in B tree and pointer pointing to document, and we can retrieve the result. So the average time complexity for retrieval will be big of log n. So this is the time complexity for retrieval in the B tree. So this is the time complexity for retrieval of data in the B tree. So as you can see, so this is logarithmic time complexity and this is the linear order of time. So as we can see, there is a drastic change in the time complexity. That's why indexing matters while querying your particular data. Okay. Now indexing is very much beneficial for faster filtering, faster sorting, and it is efficient on data written in the disk, and we can apply range based queries. So these are the general benefits of indexing in the MongoDB query. Now let us look at how indexing looks like in MongoDB. Okay, so let us take an example. Let's say there is a collection of users and I want to apply index through age field. So age is particular field available in the user's document, and we will have the following documents in this particular collection. So let us assume some documents. So underscore ID 1, name Rahul, and age is around 25. and ID underscore ID. 2, name is Mehul and age is around 28 and underscore ID. 3, name is Rohit and age is around 30 and underscore ID. 4, let's say name is Vanshika. Let's say age is around 22 and let's take two more documents. Name is Sam, age is around 35 and underscore ID. 6, name Albert, let's say age is around 32. So these are some of the documents which will be available in this users collection. And if I apply this particular index on this age field, so we are going to maintain a B tree, which is the balance tree. So this will be visualized like this balance tree. So here will be our root. So this particular root can have multiple keys within a particular node. Unlike in binary tree, we can have only one node, but in B tree, we can have multiple nodes. So this the root of the node will be dynamically set up. So on the left side, we will have the smaller one, smaller value, and on the right hand side, so this will be 28, and let's say we will have the 32, and the smaller value than 28 will be on the left subtree. So here will be 22 and 25. In order to balance, the smaller value will be at the left side and the larger value will be at the right side. And in the middle, the values must be in between 28 to 32. So we have the 30, which is in between the 28 and 32. And on the right hand side, values will be greater than 32, which is 35. So this is a general representation of the balance tree. So here the time complexity of retrieval is around big of log n. So it is a standard time complexity for the retrieval, and each node is a combination of index key plus the pointer pointing to document. So this is a broader view of the index in the MongoDB. Okay. Now let us see how to apply index in the MongoDB. So applying index in the MongoDB is very much easy. So let us see the syntax. So we will have DB, then the name of the collection, then create index, and we will have the field, and we will have either one or -1. So db dot collection dot create index. Here we will have the field. So here will be -1. So the one denotes the ascending order. and -1 denotes the descending order. Okay. So this is the basic syntax of creating index in the MongoDB. Now to check whether index exists in the collection or not, we generally check by this. So here will be our DB, which is the current database, then the name of the collection, then we get indices, and whatever the indices has been created in this collection, we will get the result. And whenever we create a particular index into the collection, we return the name of the index. So name of the index is written by this particular method. So I hope you got it. And let us see the syntax for dropping the index, or you can say the removing of index. So it is very much easy. So here will be our DB, then collection, then we will have drop index, and here will be the name of the index in the parameter, and then semicolon. And if this name exists in the index, so this will be removed from our collection, and it will be successfully executed. So I hope you got it, and let us see some practical exercise in order to understand the indexes. So we are back in our Mongo shell, and let us create a new index on the students collection. So let us select this db.students, then create index. So let us consider an example where we are querying our students document on the basis of email very frequently. So let us mention this email field, and let us create with the descending order. So this is our name of the index. So email underscore -1, and let us query about our documents. So what I have done is I have copied a particular email. So let us keep it in a single quotes. And so we are able to fetch our document with the help of email. And let us check how many indices are there in this students collection. So get indices. So we will have these two indices because by default, whenever we create a particular collection, so this index, which is for the primary key, is already created automatically by the MongoDB. And second one is our custom indices, which has been applied on the email field. So this is very important concept, which means that we are already creating an automatic index of underscore ID, which is for the primary key. And then let us drop this index. So db.students.drop index, and let us provide the name of the index, email underscore -1. So we are able to drop this particular index, and let us retrieve all the indices. So we only have this one index, which is for the primary key. Now let us take another example. So db.courses dot create indices. So we will apply this indices on the title with the ascending order. So now we have created a new index on the title. So let us query this particular course, courses.find title, and let's say we want to apply a regex, and let's say it is starting with Java or not. So yes, we are able to fetch all those courses where the title is starting with the Java. And if I want to retrieve all the indices, so db.courses.get indices. So we will have this two indices. So because previously we have applied a text index in our previous video, so we have total number of indices is three. First is for underscore ID, which is the primary key, and second is the text index, which we have applied for the searching, and the title underscore one is for the title field index. So let me drop this index db.courses dot drop index, name of the index title underscore one. So now we have removed this particular index, and if I retrieve again, so total number of index is 2. So I hope you got it. And let us understand uh, how to get the execution stats for this particular query. So let us say db.courses.find, and let's say our title must start with this. Uh, so we will use this regex, and we will have the Java again. Now we will use this explain method, which generally provides the execution stats for this particular query. So when we execute this particular query, this is the following stats for this query execution. And if you notice, then there is particular stage which is known as call scan. So its full form is the collection scan. So here we haven't applied the index on this particular title, which means this scanning of the document is applied on the whole collection. So it will check the documents one by one. So it will be take more time as compared to we have applied the index before. So let us clear this screen and let us apply this particular index on the title. And if I execute this statement again for getting the execution stats, then what we are going to get is this stage, which is different. So it is index scan. And if you see, um, let me show you the query execution. So this is the execution time in milliseconds. So previously, when we applied the call scan, it was taking around the 10 milliseconds. And if I applied this indexing on the title, so our execution time is reduced by 4 milliseconds. Although it is a very negligible change, but when we apply the index on the large number of documents, then this will be a significant difference. So I hope you got it. And let us understand more number of indices which we can apply in MongoDB. Now let us discuss about this ETL index, which is time to live index. So it basically creates an index on which document will be automatically deleted after some period of time. So it is basically used for storing some temporary documents in your particular collection. Let's say there are many use cases for TTL index, use cases for TTL index. Let's say you want to store some cache data, you want to store any session related data, which may contain user related information. So when you log in and you may create a particular session for this user, then you can store the session details inside this MongoDB collection using the TTL index. And you may use for OTP related purpose, OTP storage. Then you can store logs, temporary logs. So in broadly, whenever you want to store particular documents for some period amount of time, then you can use this TTL index. Now let us understand how to create this TTL index within your MongoDB collection. So let us look at the syntax. So here you have your current DB, then your collection, okay, and then you will have this create index, and let's say this is your field, and the syntax for this will be same. So one for ascending and minus one for descending. Okay. And then this will be the second parameter. So here will be expire after seconds. So we need to provide this particular value in the seconds to ensure that after X amount of seconds, this document will be expired and automatically removed from the collection. So this could be any value. So this is the basic syntax for TTL index. Now let us take an example. Suppose you are storing a logs collection where you are storing your logs on the temporary basis. So let's say I create an index. Sure. Okay. So we will be applying at created at, and one important thing to be noted that this TTL index must be applied on this particular field, which is of type date or date time. So whatever field is storing date related data, then here we need to apply this TTL index. And here will be the second argument. So expire after seconds is around 300 seconds. Okay. So after every 5 minutes, whatever the documents are expired will be removed automatically. So this is the basic example and this is the syntax. Now let us look uh, within the Mongo shell to demonstrate this TTL index. Okay. Now we are inside our Mongo shell within the compass. So let us create a new collection. So db.create collection. And then we need to provide our collection name. So logs will be our collection name. So we have created our collection successfully. Now let us create a particular index. So create index. So here we are going to create an index on the created at, and let's say we will have this second argument expire after seconds. Let's say 300 seconds. So we have created our index successfully, where after every 5 minutes, whatever the documents are expired will be removed automatically. So let us insert some data. So db.logs dot insert many, insert one. Let's say here is a message, logging one message inside MongoDB collection. And let's say this is our created at, yeah. So we will have this field created at ISO date. So it will pick current date time. So we have successfully inserted our document. Let's say we will insert our new document again, logging another message uh, just after collection one. Okay, so this is the random message that I have created. So if I fetch this um, documents inside this log collection, so we will be having this two documents available because they are not expired right now. So let us fetch all the indices on this logs collection. So we have two indices available. First one is for underscore ID, which is the primary key, and second one is our custom index, which is applied on created at. So this will be running a background. So MongoDB will be running a background thread after every 60 seconds and will check whosoever documents are expired already will be removed from this particular collection. Okay. So we will be waiting for 5 minutes and let us again query. So we have waited for the 5 minutes and as you can see, so I have queried my logs again using this find method and I am not getting any result because after the 5 minutes, these two documents were expired and they were automatically removed by the MongoDB. So let us query it again. So as you can see, it's that there is no documents available in this logs collection. So this is the all about the TTL index. And now let us understand the text index. Now let us understand this text index. So it is a very special type of index in the MongoDB. So what's the main purpose of the text index? Let us understand. So it helps in implementing the full text search functionality. So whenever we want to implement a search functionality within the MongoDB, then this text index is very much helpful. Irrespective of the whatever the fields you select, it will automatically search in those fields where you have applied the index. So let's take an example. So let's say I want to search for Java development in my courses collection. Okay. So for now, we are going to search for this text within this title field, which is available in the courses collection. So if I don't apply the text index, so my query will look like this. So db.courses dot find and title and then the Java development. So if I write this query, it will check for the exact text within the title field of each and every document in the MongoDB collection. But what if this Java development is in between the text or is at the end of the text? And what if I want to search not only the title but also in the description or in the any other field which contains the text value? So in this case, we can use this text index. So let us see the syntax of how to create a text index. So we will have this DB, then the collection name, Then we will create an index, and then we will have this field, and we will have the text as the value in order to ensure that we are creating the text index. So this is implemented for the single field. And if I want to implement the text index with more than one field, so we will have this syntax like this. So db dot collection dot create index, and then we have this field one text, comma, field two text. So with the combination of field 1 and field 2, we are creating a new text index. So in return, we are going to receive the index name of this newly created text index. So this will also return this index name. And this is the basic syntax for applying the text index. Now, how to query a particular data using the text? So we will have this db dot whatever your collection name is, and then we will find, and to apply the search, we will have this text operator. And within this text, we are passing a nested document, and then the search operator. And whatever the text you want to search, we just pass it here. And once you execute it, you will be able to get the result. So this is the syntax for searching using text index. So let us go into our Mongo shell and let us have the hands-on exercise on text index. Now we are inside of a Mongo shell and let us create a new text index. So pv.courses.create index, and then title, and then text. So we have created this text index on the title field, and let us search for our course. So db.courses.find, and then this text operator. We will pass the nested document, and then the search. Let us search for the Node.js. So we have this particular course where title is having this Node.js. So if you carefully see that this Node.js is written in different case, and we are passing this Node.js in the different case. So irrespective of the case, we are able to search for our text with the help of this text index. Now let us drop db.courses.drop index. So we will drop this title underscore text. So we have removed our text. Now let us create this uh, text index with the help of multiple fields. So we will have the combination of title and the description as text. So now we are able to create a new text index with the help of title and description. And if I implement this search functionality, so instead of providing the Node.js, let us provide whether we are able to get our course with the help of this express. So yes, we are able to fetch our course with the help of this express text because it is available in the description. So let's take another example. Let us search for the Kubernetes. So yes, we are now able to search for our course, which where the description is having the text of Kubernetes at the end. So irrespective of the position or the case sensitive, we are able to search for the particular text using the text index. So let us move to our screen and let us understand more about when we should not use the index and indexing best practices. Now let us understand that when we should not use the indexing. Although indexing is a very powerful tool for improving your retrieval speed of your queries in the MongoDB, but there are some scenarios or use cases where we should not apply indexing. So let us see one by one. So we should not implement indexing in the write heavy scenarios. So indexing is very much beneficial for reading scenarios where read operation is more than the write operations. But if there is an application where writing of data is more than the retrieval of data, then indexing could be an overhead because we need to manage this B tree, which is the balance tree, which is backing the indexing. So this would be modified again and again, which could be degrading the performance of the MongoDB queries. So this is the first point, that we should not implement the indexing in the write-heavy scenarios. So application where insert and update is more than the retrieval, we should not apply the indexing over there. And third point is the frequent update on this particular field, then we should not apply indexing on that field. For example, in the login scenario, so when user login into the application, we are managing this field created at. So this is up. So so let us change it. Last login at last login at. So this is the field which frequently updates on each and every login of a user. Then in this scenario, we should not apply indexing on this particular field because this could be the challenging while maintaining the B tree for this particular field. So we should not apply on the frequently updated field. And fields with the less cardinality, at this scenario, we should not apply the indexing. For example, there is a field called as gender. So we generally know that gender has only 2 to 3 values like male and female. So the field with the less option, in this scenario, we should not implement indexing on this gender. Either than we should have implement indexing on this on the fields such as email or phone number. In this scenario, we should apply indexing on this field rather than on the gender field. Okay, so this is the fourth point. And the collection with the less number of documents. Also, in this scenario, we should not implement indexing at the moment because this will be an overhead of managing the data structure if we have less number of documents in that collection. So indexing would be very much beneficial if we have large amount of documents in the collection. And the sixth point is we should not implement multiple indexing on the particular collection. Max 1 to 2 index is sufficient because more memory consumption will be there. Consumption if multiple indexing is applied. Okay, so we should limit our indexing on this particular collection. So these are the scenarios in which we should not implement the indexing. Now let us understand what are the best practices for the indexes. Now let us understand the best practices for indexing in order to improve the retrieval speed of the MongoDB query and to properly implement the indexing. Now, first of all, is we should apply indexing on those fields where filtering is frequently applied. So let us consider some examples. Let's say we have the courses collection, and within this courses collection, title is frequently used for the filtering purpose. And let's say for students, email is the field for frequently filtered. So we generally use email for the filtering of the students and title for the courses. And let's say again we have the uh, enrollments. So enrollments. So we have the student ID. So which is being used for filtering purpose. So in this scenario, we should apply indices on in these fields so that we could improve the retrieval speed. Okay, and avoid indexing on the fields with the low cardinality. So we have seen such examples like there is a field, uh, so field with gender which contain less values like male, female. So these are very much limited values for this particular field. Or let's say, yeah, so for gender, we should say there are limited values. So fields such as email, phone number, course title. So these are the great examples for indices. Okay. And third one is we should understand the execution of the query using the explain method. So we have seen this explain method in the examples within the Mongo shell, which we performed. So to implement the explain query, so we have this db.collection. So collection will be your any name which you have created. And then you have this find. Within this find, you have the query. And we will use this explain after the find. And let's say I want to understand this execution stats. Okay. So after you execute this whole statement, you get some data which contain all the stats related to the execution of the query. And within this, you have this indices. Uh, so there will be the strategy through which this query has been executed. So there are two values. Let's say this is the call scan, or they could be the IX scan. So if indices is not applied in this particular collection, then the call scan will be implemented, which is the collection scan, the collection scan. And if indices is applied on this particular collection, then this strategy will be used, which is index scan. Okay, so you can use this explain to understand all the stats related to this query. Now we should monitor the indices usage on the particular collection. So we have another command. So there is db.collection dot stats. So with the help of this command, we can understand all the stats related to this collection, that how much memory is being consumed by this particular index. So we can regularly monitor using this stats method. And we can use this indexing for filtering and the sorting purpose. So this is the general purpose of the indices. So yeah, these are the some of the best practices which we can follow for the indices. And here it is the end of our lecture. So in this lecture, we have understood what is indexes and how to apply various kind of indexes, how index is being managed by the MongoDB, the B tree structure, and what are the best practices for indices and when we should not implement the indices. So whatever is your favorite part of this video, you can comment it down. And if you have any doubts related to this lecture, you can also comment, and I will be reading your comments and replying your queries accordingly. If you have gained some knowledge related to indices, and if you get to understood that what is index, then please give a like to this video and share this video among your friends so that they could be understanding more on the indices, and they could be familiar very much with the indices. And please subscribe to my channel for more such technical content. So I will be delivering more lectures on the MongoDB. So in the next lecture, we will be understanding the aggregation, what is aggregation and how to apply the basic aggregation. And we will see some operators which is used in the aggregation. So yeah, thank you for watching the video, and I will see you next time.